In this unit, we'll learn about the structure of HTTP messages and look at the various methods to transmit information from the server to the host. As we've seen in the previous unit, there are two types of HTTP messages: HTTP request, which is sent from the host to the server, usually by the browser, and HTTP response, which is sent from the server to the host. We'll start with the structure of a request, which is built of legible characters, otherwise known as ASCII. Each character weighs 1 byte. The request structure is made up of characters, part of them special, so that each has an important meaning. The first line contains the type of request, the route of the desired object, and the protocol version. Next are the header lines, which contain information about the client, such as his browser type, communication type, language, etc. Between each and every line, there are two special characters, /r/n, which represent the end of a line. In this slide, you can see the format of the message clearly. If we send a message in the wrong format, even by a single character, the ability of the server to understand the client will be disrupted, and things won't work properly. SP represents a space, CR represents /r, and IF represents /n. These are special characters that take up 1 byte. Note that in the last part, there is an additional part, which is the body of the message. What information does the customer need to send to the server in the body of the message? We will answer this question in the next slide. In order to look at every object, we can view this as a function. The function receives parameters from the client and returns a value, which is an object which fits these parameters. If the object is static and has no parameters at all, we'll say that the function has no arguments. A web page, which is a form with fields to fill out, is a definite function. The client can transmit the parameters with the requests for the form results. There are two methods to request an object from the server in which parameters are transferred: the POST method, where parameters are transmitted at the end of a message, that is, in the last part of the request, and the GET method, where the parameters are transmitted as part of the URL itself, where it is chained and alternately equivalent with an ampersand, which is an AND character between them. It's important to note that each method has advantages and disadvantages. The GET method allows saving an address that contains the parameters so that, at a later stage, it'll be possible to refer directly to the correct object parametrically in the server. The POST method allows encrypting the information in the body of the message and hiding the data from hostile elements. This method also allows compressing the data and manipulating the parameters in a way that isn't possible in GET, because the GET method has to adhere to the defined format. The structure of response messages is also the same, and it contains in the first line the response status and the protocol version. In the future, we'll see different mechanisms with which the server can respond to the client. Then the header lines will contain additional parameters, such as the date, time, the server type, its OS, when the object was recently updated, which is very useful data we'll deal with later, the file type, etc. The last part will contain the object itself, like the client asked, assuming everything was fine. In this message too, every line has to end with /r/n, except the object data part. The server can return varying statuses to the client, which requested an object from it, meaning a page or anything else. The status is in the first line of the response message. Status 200 OK means the object has been found and is attached to the message. Status 301 indicates that the requested object has been moved to a new location, which is specified in this message. Status 400 indicates that the message was not understood by the server. 404, object not found. 505, the HTTP version is not supported by the server, etc. In this unit, we learned of two methods for sending requests from the client to the server: the GET method and the POST method. Additionally, we got to know the structure of message content and the various statuses the server can report to the customer.